Hello, this video is for 2.5 derivatives of quotients. By now you should be pretty comfortable with the power rule, the product rule, and the chain rule. The only one left is the derivative of quotients, or fractions. So to find the derivative of quotients, we're going to use the product rule to derive a way to differentiate quotients. So let's recall, if I had something like that, 3y over x squared, I can rewrite that using exponent rules as, I could bring this to the top, and I can rewrite that as 3y times x to the power of negative 2. Remembering that negative exponents allow me to bring it either down or to the top. So for example, if I had 3y over x to the power of negative 3, that is the same thing as saying 3y to the power of x positive 3 if I bring it to the top. Okay, so in this case, x2 allows me to bring it to the top and make it negative. Okay, so we're using that same logic over here. Fx is equal to px over qx. If I want to find a way to differentiate that, let's simplify it by bringing qx to the top. If I bring it to the top, that means it now has a negative exponent. From there, that looks like the product rule, doesn't it? So we're simply applying the product rule. So using the product rule, the derivative of px times this whole thing without changing anything, okay, plus px without changing anything, just copying it, and the derivative of qx, okay, so bringing the negative 1 down, negative 1 subtract 1 is negative 2, and then chain rule, derivative of what's inside, okay. So now if I simplify this, I end up with that, which is the derivative of fx if fx was px over qx. Okay, now that's just a quick little proof as to how we come up with this formula to find the derivative of any quotient. Okay, you don't need to really necessarily know it, but it helps to understand it. Really, you just need to be able to apply it. So for example, if we have gn is equal to n cubed over 2n squared minus 1. Applying the quotient rule, what we would do is, now follow the colors, find the derivative of what's on top first to get 3n squared. Okay. And then copy 2n squared minus 1, copy that down. Minus now, okay, as opposed to plus in the product rule. Copy down the top, which is just n cubed, and then the derivative times the derivative of the bottom, which is just 4n, and that's the top done. And the bottom, I just simply rewrite it and then square it. Okay. Now from here you could try to simplify it, but this is calculus, so we're not looking at testing or looking at your ability to simplify equations. Okay, you should be pretty comfortable doing that by now. So when we're dealing with the product or quotient rule, I would prefer if you left it unsimplified, okay? Because this shows me that you've used the rule correctly, okay? And then if you need to sub anything in, you can just sub it into this, as opposed to going through the extra step of simplifying, okay? So that's done. Here's another example. Differentiate fx equals to 2x minus 3 over x squared minus 4x. So again, we differentiate the top, which just gives me 2. Then we copy the bottom without changing a thing. Then we flip it, subtract the derivative of the top, or sorry, I lied, not the derivative of the top, just copy the top, times the derivative of the bottom, which is just 2x minus 4, 2x minus 4. And then divide it by, copy the bottom, squared. So it's asking us to find the rate of change when x equals to negative 1. Notice I didn't simplify anything. I just went right ahead and subbed in x equals to negative 1 to get a derivative of negative 4 over 5. So I simply just typed all this in my calculator to get negative 4 over 5. Done. Okay. Differentiate y with respect to, again, we're doing the same thing. Okay. It looks a little bit more complicated, but it's the same. So y prime would be the derivative of the top, which is just 5 times 2x minus 4, 2x minus 1, sorry, to the exponent 4, times 2, y times 2, chain rule. Okay, so after you differentiate the outside, you got to differentiate what's on the inside. So 2x minus 1 is on the inside of that bracket. When you differentiate that, you get a 2 times the bottom, root 7x plus 8, subtract, copy the top, and then differentiate the bottom. Now, before you differentiate the bottom, remember that root of 7x plus 8 is the same thing as saying 7x plus 8 to the exponent of 1/2. They mean the same thing. For example, 9, root 9 is the same thing as 9 to the exponent of 1/2. Okay? So then, to differentiate that, move the 1/2 to the front, and then 1 minus 1/2 is negative 1/2, and then the derivative of the inside is just 7. And again, copy the bottom squared. Okay? Again, now imagine trying to simplify that. This would be it would be messy, not impossible, but messy to simplify that. And that's pretty much it. Okay? So just practice working with the quotient rule. Okay? See you in the next video.